we have discussed regarding the carbonyl compounds of aldehydes and ketones, and how we are going to give the IUPAC nomenclature for the carbonyl compounds, including aldehydes and ketones. Both we have discussed, along with the aliphatic and cyclic rings. Both we have discussed. Aromatic rings also we have discussed yesterday. Now, some more compounds they have given. We will see those compounds, how we are going to pronounce itself. If both carbonyl compounds are present in the given component, like what, and one is ketone and one is a aldehyde here itself. Once you will see clearly the first compound what they have given, C double bond O, H it is there, as it is in the end of at the end of the compound, as well as at the middle of the compound ketonic group is also present here. Because of that reason, what, which group can be called as a prefix and which can be called as a suffix? If two functional groups are there, the group which it is present as a ketone, that can be used as a prefix. So at that time, the ketonic group can be called as oxo. And you are counting, we are counting the numbers and we are giving the priority from the aldehyde carbon. So the first pink color carbon, we are going to give the first priority. So from that carbon onwards, if you are going to give the priority, there is a first carbon, and CH2 is the second carbon, and the third carbon ketonic group is there. Because of that reason, it can be called as with a prefix. It can be known as oxo. At third carbon, oxo is there. 3 oxo we are calling, and total number of carbons will be 5. Because of that reason, pent is the root word, and aldehyde group it is present in the case of IUPAC nomenclature. Aldehyde can be called as what, all here itself. Because of that reason, we are calling it as pentanol. So the actually pentane it will be there. A third position ketonic group is there. Because of that reason, we are calling it as 3 oxo, and the last carbon aldehyde group it is there. So we are calling it as what, all. That's why it is a 3 oxo pentanol. Similarly, if you have taken the next one, 2,4 dimethyl pentane 3-one, we are calling the long chain. First we are going to observe, that is also the root word will be pent, and at second carbon and fourth carbon we have 2 methyl groups. That's why 2,4 dimethyl pent we are calling. And at third carbon, clearly we are having a ketonic group. It is also a secondary suffix here taking, and it will be 3-one we are saying. 2,4 dimethyl pent 3-one also we can call, pentane 3-one also we can call. Similarly, if you have taken the ring of a benzene group, aromatic group here we are taking, that is 4 nitro benzene carbaldehyde we can take here itself. So the benzene is the first prioritized group. Because of that reason, the benzene number here we are going to give, that is the carbon, first carbon will be. So CHO carbon will be taken as the first carbon, and on the right side, from the left side, both if you have considered, the nitro group is going to get the fourth position. Because of that reason, it can be called as 4 nitro benzene carbaldehyde we are calling. Otherwise 4 nitro benzaldehyde also directly we can say clearly. Okay, once you observe clearly the component, what was different because 3 carbons are there, those are propane we can call, and the 3 aldehyde groups are attached to the 3 carbons. Left side is one and right side is one, and the middle carbon is also having the aldehyde group. Upon every carbon, one aldehyde group it is there. Because of that reason, it can be called as, at first position aldehyde is there, second position and third. So we call it 1 comma 2 comma 3. How many aldehydes are there? 3. That's why tri carbaldehyde. So in this manner, we are going to give the IUPAC names of some aldehydes and ketones. So similarly, some table also given. So many compounds are there. If we have seen HCHO can be called as formaldehyde. It is a general name. But whereas if we have taken methanol, methanol in the sense we are having of what, especially only one carbon is there. Because of that reason, it can be called as a root word, meth will be. And IUPAC names in aldehyde group it is present, it can be called as what, all. So meth is a root word, and aldehyde going to call it as all here itself. So because of that reason, meth is the root word, and suffix we are going to call, secondary suffix will be what, all. Because of that reason, the combination of meth and all combinedly we can call it as what, methanol will be. Similarly, if you have taken the second compound, the general name it will be acetaldehyde. So if you observe the carbon, number of carbon presence in that what, ethanol. Why we are saying ethanol itself, the in the aldehyde group, the carbon whatever it will be present, that carbon also will take into the consideration, and we will count the carbon also. Along with that carbon, if we will count, 2 carbons are will be present in the acetaldehyde. So the eth is the root word, and all is the IUPAC, the secondary suffix functional group suffix here it will be. Because of that reason, it can be called as what? Ethanol. Similarly, if we have taken isobutyraldehyde, isobutyl group is there and aldehyde is the secondary suffix we are calling. Once you observe clearly for completion of the aliphatic aldehydes, if we will see the aromatic aldehydes upon the benzene ring, two aldehyde groups are there. One is on the first position and another one is the second position. That can be called with the general name of phthalaldehyde. దాన్ని ఏమంటున్నాం మనం ఇక్కడ థాలాల్డిహైడ్ అని చెప్తున్నాం. సో ద థాలాల్డిహైడ్ it will be there, then it will be called with a IUPAC nomenclature. Why we are calling, how we are calling, if we will see benzene ring is, it is normal, it is present, and upon the benzene ring at first position and the second position, two aldehyde groups are present. So because of that reason, it can be called as what? Dicarbaldehyde. Why we are calling dicarbaldehyde? Two aldehyde groups are present. Because of that reason, it can be called as what? A dicarbaldehyde. So we are calling it as benzene dicarbaldehyde at positions with 1,2 dicarbaldehyde. Halo substituted benzaldehyde, if we will see, from the aldehyde carbon onwards, we are taking as first carbon. And bromine will be present at which carbon? If you'll observe there, at third carbon. So we are calling it as what? 3-bromo-benzaldehyde we can call. Why? Because at a third carbon bromine is present. Because of that reason, it can be called as 3-bromo-benzaldehyde. Okay, clearly. So ketones, ketones observe. Ketones we can observe here. So how we are calling as ketones? We know that aldehyde group is going to exist at the end of the compound, but ketones are going to exist at the middle of the compound. So because of that reason, how we are going to pronounce as the ketones, we'll see here. Total number of carbons including the ketonic carbon also we should take into the consideration. After that, what? The second carbon, the second carbon, here the second carbon will be what? Exactly, the second carbon contains the oxygen and that is a ketonic group. 1, 2, 3, 4, 5 carbons are there. Where 5 carbons are present, the root word here we are taking as pent, and at second carbon we are having one. So pent to 2-one we can call. Otherwise we can call it as 2-pentanone. Otherwise 2-pentanone or pent to 2-one also we can say. Pentane 2-one will be. So means similarly, if you have taken a cyclic ketonic group, it is present upon the benzene ring, double bond O is there, and that carbon is taken into the consideration as the first carbon. After that ketonic group, one methyl group, it is there upon the beside carbon. Because of that reason, that can be taken as the substitution. So that can be taken as the second carbon, and upon the second carbon, one methyl group it is there. So it is 2-methyl cyclohexane is called. It will be. We are calling it as what? 2-methyl cyclohexane. Okay. So its a general name will be alpha methyl cyclohexanone. We can call alpha methyl cyclohexanone. Why we are calling alpha methyl cyclohexanone? The functional group attached carbon can be called as what? It will be the alpha carbon, and the functional group attached carbon beside carbon will be the beta carbon. So similar in this similar manner, we are going to give the nomenclature of aldehydes and ketones in general. Okay. So already if you have structure of the carbonyl group, how it will be? See clearly, students. When CHO is there or C double bond O is there, if it is an aldehyde or ketone, whatever it may be present, carbon have 3 single bonds and 1 double bond it will be present along with the carbon. So it indicates what? Carbon, which when it is under the hybridization, when it is having the double bond, that carbon must and should having the hybridization of a sp2, we can say clearly. So either the carbon which it is present in the aldehyde group, either the carbon which it is present in the ketonic group, definitely these are the carbons are having the sp2 hybridized carbons, we can say clearly. Okay, for that and the next whatever it present double bond, the second is present in the double bond, that can be what? It is a pi bond, it is a very weak bond, and the bond angle in the sp2 hybridization, we know that, we are aware of that, that is 120 degrees will be. Okay, so this T double bond group can be existed as in the form of clearly C double bond exists resonance structure B. C double bond O it can form, otherwise CO minus by migrating of electrons to the oxygen. Because of higher electronegativity, oxygen is going to get a negative charge and carbon is going to get the positive charge here itself. So carbon oxygen double bond, it polarizes because of the electronegativity. The migration of electron takes place towards the oxygen. Because of that reason, the carbon as an electrophilic and carbonyl oxygen is a nucleophilic centers. ఎందుకంటే oxygen is having the negative charge by the migration of electrons, and carbon is getting the positive charge because of it is an electrophilic center, and oxygen is the nucleophilic center. So because of that reason, what carbonyl compounds have a substantial dipole movements clearly, and are polar than ethers also more, and are polar than ethers clearly are saying. That means polar in the sense what they are going to dissolve in that. The high polarity of the carbonyl group in explained in the basis of what a resonance involving a neutral A and a dipolar B structures are shown here. You see, here will be the neutral structure. Why? Because there is no charges are going to exist on the oxygen and the carbon. Whereas in the second structure here we are going to see two charges we are getting. That's a dipoles. Will be dipoles in the sense of positive pole and the negative pole. Because of that, dipolar charge structure and as well as the neutral structure. Clearly, we can explain it. Okay. After that, after completion of the IUPAC nomenclature of the carbonyl compounds like aldehydes and ketones, if you will see clearly, we are going to discuss about what a preparation of aldehydes and ketones. So how we will prepare aldehydes and ketones? In the previous lesson we have seen the chemical properties of alcohols. Alcohol chemical properties lo మనం చూసినాం aldehydes ni ketones ni ఎట్లా ప్రిపేర్ చేస్తామో. Okay, for this what by oxidation of alcohols. Aldehydes and ketones are generally prepared by the oxidation of primary and secondary alcohols. Alcohols ni కనుక మనం ఆక్సిడేషన్ కనుక చేస్తే మనకు aldehydes అనేటటువంటివి ketones అనేటటువంటివి ఫామ్ అవుతాయి అని చెప్పేసి అన్నాడు. ఓకే, ఆఫ్టర్ దట్ dehydrogenation of alcohols. Alcohols in this dehydrogenation in the sense removal of hydrogen. Dehydration anetledu akkada dehydrogenation antunnadu. Because of that reason we are removing the hydrogen. At that time we are going to get the aldehydes and ketones, and this process can be done by the when alcohol vapors have passed over heavy metals like silver and copper to the primary and secondary alcohols give aldehydes and ketones. In the first and second case, both the cases, we are not taking the tertiary alcohols. Only we are considering what first and secondary alcohols. That also we have discussed in the alcohols. Why we are taking primary and secondary. Tertiary alcohols and beta elimination reactions are going to occur. That we have clearly discussed. From hydrocarbons in the set might be alkanes or alkenes or alkynes. These are all called hydrocarbons only. Hydrocarbons అంటే తెలుసు కదా, హైడ్రోజన్ కార్బన్ మాత్రమే ఉంటాయి దాంట్లో. Those are what alkenes and alkanes and alkanes will be. Of alkane. Already also in the first year we have discussed what already know alkenes ni ganaka ozonolysis cheste manaku first of all adduct form avutadi. Every oxygen is going to involve in the reaction by breaking of the double bond in alkenes. Appudu adduct form ayin tarvata again the reaction is followed with zinc dust and water gives what aldehydes. But also it is available. Okay, in the next preparation if we will see clearly, so ketone picture of both depending institution pattern of the alkane will be. So next process is what by hydration of alkynes will be. Hydration in the sense reaction with water of a triple bonded hydrocarbons. Addition of water to ethane in the presence of H2SO4. Addition of water in presence of H2SO4 and mercury sulfate also if we have taken, which is having a acidic nature, high acidic nature. At that time we are going to get as what ketones clearly. So these are the general preparation of aldehydes. So let we all observe from acyl halides if we have taken how they are going to form aldehydes. See, first we have taken benzoyl chloride. Benzene is there upon that acyl group. If we have taken, that can be called as what benzoyl chloride. That benzoyl chloride undergoes hydrogenation. Benzoyl chloride undergoes hydrogenation in presence of a catalyst like a palladium barium sulfate. It can be called as Lindlar's catalyst. Palladium barium sulfate catalyst మనం ఏమని చెప్తాం అక్కడ Lindlar's catalyst generally we can call is hydrogenated over the catalyst palladium and barium sulfate. This reaction is known as what Rosenmann's reduction చెప్పేసి చెప్తాం. ఇది ఒక named reaction. Named reaction very important in this, and it is palladium and barium sulfate presence low. If the benzoyl chloride undergoes hydrogenation, at that time aldehydes are going to be formed clearly from nitriles and esters. Okay, what are nitriles? Nitriles are what cyanides we can call nitrites will be. Okay, when alkyl cyanides when treated with stannous chloride in presence of HCl with on hydrolysis, they are going to give what corresponding aldehyde here itself, and the reaction is going to occur in two steps. What it is forming there, if we will see clearly, when we have taken cyanide group methyl substitute, sorry, methyl cyanide, any alkyl cyanide if you have taken, that alkyl cyanide is treated with the stannous chloride and in presence of HCl, if the reaction is going to be occurred, at that time we are going to get say imines. Okay, and H can be called as an imine, and H2 will be there, it can be called as what amines will be. So double bond, and when where the cyanide group contains of a C triple bond N, and between carbon and nitrogen triple bond it is present, because of the high electronegativity of the nitrogen, the polarization of the bonded electrons, one of the bonded electrons are polarized towards the nitrogen. Because of that reason, nitrogen is going to get the negative charge and carbon is going to get the positive charge clearly itself. So because of that reason, one of the hydrogen is going to treated with the hydrogen carbon, and one of the hydrogen is going to treated with the nitrogen. At that time, what imines are going to be formed? These imines, when treated, when undergoes hydrolysis, at that time aldehydes are going to be formed. This is called as what? A Stephen reaction. So this is one of the named reaction. Okay. After that, alternatively, nitriles are selectively reduced by the diisobutyl aluminium hydride, that we can call it as dibal H. And simply we can call it as what? Dibal H. Two imines. Already I said na. Ikkada alternatively, nitriles also selectively reduced by, instead of this HCl, if we have taken dibal H also, these are the nitriles are converted as imines in place of water. In place of HCl, if you have taken dibal H also, at that time there is a chance of conversion of these two things will be into the amines clearly. Okay, amines followed by the hydrolysis of aldehydes. Then alkyl cyanide we have taken. After that, aluminium dibol, here it will be what we are taking here clearly you can observe. When alkyl cyanide undergoes the reaction dibol H, as well as in presence of water, it is undergoes hydration and it is forming as what clearly aldehyde groups. Similarly, if you have taken instead of that methyl group, we have taken alkene cyanides will be. See clearly how many carbons are there? 1, 2, 3, 4, as usual 5 and 6. These 6 carbons undergoes the treatment of dibal H as well as with H2. So directly we are going to get the same number of carbon substituted aldehydes are going to be formed, and there is no change in the double bond. No double bond will get be affected by the reagents what we are taking as dibal H and hydration process. Because of that reason, here clearly we are going to get a compounds of what? Aldehydes. Now after that, similarly in case of nitriles, if we have taken esters also, if you have taken esters also, we are going to get aldehydes. Then what are the reagents? The same reagents here we are taking. In the first case we have stannous chloride and HCl, but in the second case, and for every compound we are considering as what? Dibol H as well as a hydration reaction clearly. Okay, so this is one of the preparation process of aldehyde from nitriles and esters. See children, nitriles in the sense we can call it as a general name is nitrile, but generally we can call it as what? Cyanides will be. Okay, and NC it will be there, it can be called as isocyanide will be. NC it is there, isocyanide. CN will be there, it is called as cyanide itself. Okay. After that, from hydrocarbons, if we will see aromatic aldehydes are prepared from the aromatic hydrocarbons by the following methods. What is the following methods? Let we will see once. First, he has taken as toluene. Upon the benzene ring, if methyl group it is present, it can be called as what? టోలిన్. ఎప్పుడైనా బెంజిన్ రింగ్ పైన మనకు మిథైల్ గ్రూప్ ఉందనుకోండి, దాన్ని టోలిన్ అని చెప్పేసి పిలుస్తాం. అదే మనం ఇంతకు ముందు ఈథర్స్ లో చూసినాం. అపాన్ ద బెంజిన్ రింగ్ ఆక్సిజన్ విట్ విల్ బి ప్రెసెంట్ beside of the oxygen. If CH3 group it is there, it can be called as an anisole will be, or methyl phenyl ether also we can call. Otherwise we can call it as an anisole with a general name. అది ఈథర్స్ లో చెప్పుకున్నప్పుడు. మరి ఇక్కడ ఏం చేస్తున్నాం? Upon a benzene ring, one methyl group it is there, that can be called with a general name of toluene, otherwise methyl benzene also. So this toluene, when treated with chromium oxychloride in presence of carbon disulfide, దీని సమక్షంలో కార్బన్ డైసల్ఫైడ్ ప్రెసెన్స్ లో, ఇట్ ఈస్ ఏ హై నాన్ పోలార్ సాల్వెంట్, మంచి నాన్ పోలార్ సాల్వెంట్ ఇది. ఈ నాన్ పోలార్ సాల్వెంట్ ప్రెసెన్స్ లో కనుక ఇఫ్ యు ఆర్ ట్రీటింగ్ దిస్ what exactly methyl benzene, when methyl benzene is treated with chromium, we treated with chromium oxychloride in presence of carbon disulfide, at that time one complex we are going to get, that is along with a reaction of chromium oxychloride, chromium complex is going to be formed with toluene, and when it is undergone hydrolysis, again we are going to get the benzaldehyde. So means by means what? In the previous reactions, in order to get the aldehydes, in the second step we did the hydrolysis, as well as in the similar process for the aromatic, in order to get the aromatic aldehydes also we have to do the hydration process. But the first step it will be what? Chromium oxychloride here we have taken, but whereas in the manufacturing of aldehydes, of aliphatic aldehydes, there we have taken from different compounds like stannous chloride, dibal H, those we have taken. Here chromium oxychloride we have taken. Okay, so this is called as Etard reaction. So clearly observe children, Rosenman reduction we got, Stephen reaction we got, in the alcohols Reimer-Tiemann reaction we got. Here we are getting as what it can be called as Etard reaction. Directly in the exam they will ask what the named reaction. There may be a chance of asking of a named reaction. Okay, so next reaction is what they did. Once we will see, toluene or substituted toluene is converted to benzaldehyde as the same reaction which is given as above, but here in the above reaction they have taken chromium oxychloride, but in the next reaction we are taking here, it will be chromium trioxide along with the acetic anhydride will be. So when toluene is treated with acetic anhydride along with chromium trioxide at the temperature of 273 to 283 kelvins, it is going to be changed as what? Treating with aromatic oxide and acetic anhydride, the benzylidene diacetate is going to be formed. So the second compound name can be called as what? Benzylidene diacetate. This benzylidene diacetate, benzylidene diacetate will be when undergone hydrolysis. At that time, it is going to be formed as what? Benzaldehyde we can call. The name మన final step లో మళ్ళీ ఏం బాగుంటుంది అంటే second step almost in every case we are doing the hydrolysis process only. Okay, so after that the next reaction if we going to see clearly by side chain chlorination followed by the hydrolysis. ఇక్కడ మళ్ళీ టోలిన్ అయితే మిథైల్ సబ్స్టిట్యూటెడ్ బెంజిన్ మళ్ళీ తీసుకుంటున్నాం. ఈ మిథైల్ సబ్స్టిట్యూటెడ్ బెంజిన్ ఆర్ టోలిన్ undergoes the halogenation, that is chlorination in presence of ultraviolet radiation. Ultraviolet radiation presence లో chlorination ఇంకా బెంజాల్డిహైడ్ కనుక చేస్తే already we aware of that any alkanes and if any alkanes are there, if they are going undergone uh, what halogenation reaction, that is completely what free radical mechanism which is contains of initiation, propagation and termination. Three steps are there in that reaction. The similar process it can be called as what CHCl2 we are going to get, that is benzyl chloride will be. This benzyl chloride undergone again the similar process what we have done in case of aliphatic aldehydes as well as aromatic aldehydes. It undergoes on the what hydrolysis process. Again we are going to get a benzaldehyde we can get. So Itard reaction as well as Stephen reaction. Before that we have completed what? Itard reaction, Stephen reaction, and one more reaction, Rosenman reduction also we have seen. After that clearly if we will see next one is what Gutterman-Koch reaction we can call it. What is that Gutterman-Koch reaction? So let me see that Gutterman-Koch reaction. Benzene is converted as benzaldehyde. Benzene, the simple benzene is going to convert as what? Benzaldehyde will be. Benzene is converted as benzaldehyde. Okay. How it is converting? When benzene is taken, it is treated with a carbon monoxide and as well as hydrogen fluoride in presence of anhydrous aluminum chloride and cuprous chloride or cuprous chloride will be. So benzene at that time it is going to give as what? Benzaldehyde. So these are the preparations of aldehydes. Either they can be aliphatic aldehydes or they can be aromatic aldehydes or they can be cyclic aldehydes and whatever it will be. Those are completely what forming of aldehydes in generally. Next, fine. So after completion of the preparation of aldehydes, we are getting what we are watching now preparation of ketones. How we can prepare the ketones? So if we will see from acyl chlorides, already we have seen earlierly from the acyl chlorides how we have prepared aldehydes. You will observe once in the benzyl chloride we have taken H2. Hydrogenation is done in presence of palladium and barium sulfate, that is a Lindlar's catalyst, that is called at the time benzaldehyde is formed. We will see similarly here which chloride we have taken, alkyl magnesium halide, that is, and after that we have taken okay acyl chloride we are taking, and after that that acyl chloride is going to treated with a dimethyl cadmium. I think so it will be of cadmium chloride will be. Okay, right. Treatment of acyl chlorides with dialkyl cadmium. So the first step clearly if we'll observe here students, GS it is there. Alkyl magnesium halide. When alkyl magnesium halide is treated with a cadmium chloride. ఎప్పుడైతే ఆల్కైల్ మెగ్నీషియం హాలైడ్ cadmium chloride తో ట్రీట్ అవుతుందో at that time dialkyl cadmium, that is R2CD, and after that 2 MgXCl is going to be formed. After that the formed alkyl cadmium from the alkyl magnesium halide which is called as Grignard reagent, that is when treated with a acyl chloride or acyl halide, At that time, clearly it is going to be formed as what? Ketonic group or C double bond O group. It is present in the SL group. That C double bond O group up to the bond will be broken and Cl is going to get the negative charge. Carbon is going to get the positive charge. After that, what? In R2CD2 methyl groups, which is going to get one of the positive charge. Because of that reason, then one methyl group is going to treat it with one carbon. So there is a chance of formation of a ketone, and cadmium chloride is going to be formed clearly. So this is what from the using which is get from the grignard we are going to the ketones clearly. Okay, right. But here we are not getting imines when nitriles are written. Nitriles అంటే ఏంటి మరి? సైనైడ్స్ కి మనం సైనైడ్స్ ని మనము జనరల్ గా ఏమని పిలుస్తున్నాం? నైట్రైల్స్ అని చెప్పేస్తాం. సైనైడ్ గ్రూప్ ని నైట్రైల్ గ్రూప్ అని చెప్తాం. సో that cyanide group is treated with alkyl magnesium halide, that is phenyl magnesium halide, phenyl magnesium bromide, and it is treated with that at that time in presence of ether. At that time, what it is going to be happen, where there is a bond is existed in between the carbon and nitrogen. Because of that reason, the bonded electrons are migrated towards the higher electronegative atom, towards the nitrogen. Because of that reason, nitrogen is going to get the negative charge and carbon is going to get the positive charge. And after that, in alkyl magnesium halide, if we will see, here we are going to get as what? MgBr is going to get the positive charge, and the alkyl group it is going to get the negative charge. So because of that reason, the positive group, which is MgBr, is going to be attached or attacked on the nitrogen, and the alkyl group is will be attacked. Phenyl group it is going to be attached on the carbon. So because of that reason, with double bond, NMgBr is formed. After that, the second step, everywhere if you are observing, they are undergone hydrolysis only. Aldehyde preparation lo ఏ step లోనైనా కూడా what hydrolysis లోనే జరుగుతుంది. At that time, aldehydes are going to be prepared. So this is one of the preparation of, sorry, ketones are going to be prepared. This is one of the preparation of ketones from nitrile groups. అక్కడ కూడా nitrile groups నుంచి మనం ఏం ప్రిపేర్ చేసినాం? ఆల్డిహైడ్స్ ని ప్రిపేర్ చేసినాం. కాకపోతే అక్కడ ఇమైన్స్ ఫామ్ అయినాయి. ఇక్కడ ఇమైన్స్ కాకుండా, ఇమైన్స్ ఫామ్ కాకుండా మనం ఏం తీసుకుంటున్నాం? ఆల్కైల్ మెగ్నీషియం హాలైడ్ గ్రిగ్నార్డ్ రియేజెంట్ ని తీసుకుంటున్నాం మనం ఇక్కడ. ఓకే, రైట్. ఆఫ్టర్ దట్, అండ్ బెంజిన్ తీసుకుంటే మనకి ఇక్కడ ఇథైల్ నైట్రల్ తీసుకొని ఫినైల్ మెగ్నీషియం బ్రోమైడ్ తీసుకుంటే మనకి ఇక్కడ ప్రొపియోఫినోన్, వన్ ఫినైల్ ప్రోపోన్ ఇస్ క్లియర్. ఓకే, next reaction from benzene or substituted benzenes. Benzene, if you have taken aromatic acyl chloride is there, which is called as Friedel-Crafts acylation. Already we know that everywhere Friedel-Crafts acylation, in the sense the reagent will be always same. What is that? Anhydrous aluminum chloride we will take. AlCl3 will be. So at that time, what will happen? We know that very well. Acyl group is going to be attached to the benzene group, whatever it will be present. So benzene group is attached by the acyl group, whatever we have taken. That seems what acyl substituted benzene we are going to get itself. So my means what? Whatever the alkylation, Friedel-Crafts alkylation, Friedel-Crafts acylation, if both the reactions if being means whatever the alkyl group or whatever the acyl group we have taken, that is going to be attached to the compound what taken. Either it might be the aliphatic or it might be the aromatic group. So in this substituted benzenes, from the substituted benzenes or from the normal benzenes, we are going to prepare the ketones. Okay. Physical properties. Preparation completed. Nomenclature completed. General things like general names, IUPAC names, preparation. These are all completed of the aldehydes and ketones. Then what are the physical properties of the aldehyde ketones? The physical properties of aldehydes and ketones are described as follows. What are they? Methanol is a gas at room temperature. Ethanol is a volatile liquid, and other aldehydes and ketones are liquids or solids at room temperature. మనకు మిథనాల్ అనేటువంటిది ఏ ఫామ్ లో ఉంటుందంట? గ్యాసెస్ ఫామ్ లో ఉంటుంది అన్నాడు. ఇథనాల్ అనేటువంటిది ఏ ఫామ్ లో ఉంటుంది? లిక్విడ్ ఫామ్ లో ఉంటుంది. దట్ ఈస్ విచ్ ఈస్ హైలీ వోలటైల్ లిక్విడ్. అంటే మూత తీసి పెట్టేస్తే కనుక దేర్ మే బి ఏ ఛాన్స్ ఆఫ్ వాట్? ద ఇథనాల్ వాట్ ఎవర్ ఇట్ విల్ బి ప్రెసెంట్ ఇన్ ద వెజల్, దేర్ మే బి ఏ ఛాన్స్ ఆఫ్ వోలటైలిటీ, ఆవిరైపోయే అవకాశం ఎక్కువ ఉన్నది. సో the boiling points of aldehydes and ketones are higher than the hydrocarbons and ethers of comparable molecular masses. We have taken, once you observe the boiling point of N-butane 273, methoxyethane 281, propanol 322, దట్ ఈస్ ఆల్డిహైడ్. ఆల్డిహైడ్ ఎంత వచ్చింది చూసింది ఇక్కడ 322 వచ్చింది. బట్ వేరాజ్ ఇన్ కేస్ ఆఫ్ ప్రోపేన్ 1 మోల్ ఆల్కహాల్ అన్నిటికంటే ఎక్కువ వచ్చింది. ఎందుకు ఎక్కువ వస్తుంది చెప్పండి అక్కడ? బికాస్ ఆఫ్ హైడ్రోజన్ బాండింగ్. అందులో ఏవి ఎగ్జిస్ట్ అయ్యే అవకాశం ఎక్కువ ఉంటుంది? హైడ్రోజన్ బాండింగ్, ఇంటర్మాలిక్యులర్ హైడ్రోజన్ బాండింగ్ ఫామ్ చేస్తే కదా ఆల్కహాల్స్. అందుకని చెప్పేసి అవి అంత తొందరగా బాయిల్ అవ్వవు, ఈజీగా ఎవాపరేట్ అవ్వడానికి ఛాన్సెస్ లేవు. హైడ్రోజన్ ఆ బాండింగ్ బ్రేక్ చేయాలి, తర్వాత అది గ్యాస్ స్టేట్ లోకి రావాలి. అంటే రెండు కేసెస్ ఇక్కడ పడుతున్నాయి కాబట్టి హైడ్రోజన్ బాండింగ్ రిక్వైర్ చేయడానికి ఒక ఎనర్జీ, అండ్ అగైన్ ఇట్ షుడ్ కన్వర్ట్ ఇన్ టు ద గ్యాసెస్ ఫామ్, వన్ మోర్ ఎనర్జీ is required. Because of that reason it is having మోర్ బాయిలింగ్ పాయింట్. మాలిక్యులర్ మాసెస్ ఆల్మోస్ట్ ఈక్వల్ గా ఉన్నవి తీసుకుంటే కనుక మనకు వచ్చేటటువంటి బాయిలింగ్ పాయింట్స్ అనేటటువంటి ఈ రేంజ్ లో ఉన్నాయని చెప్పేసి చెప్తుంది. ఓకే, సో ద లోస్ ఆఫ్ అండ్ కీటో such as ethanol known with water in all the portions. Whatever the aldehydes which are having lesser molecular weight or which are having one or two carbons, దోస్ మిసిబుల్ విత్ వాటర్, అంటే వాటర్ లో ఏమైతాయంట, కరిగిపోతాయంట, వాటర్ తో పాటు కలిసిపోతాయంట.
Sir,
వాట్ ఆర్
kindly
నాట్
conclude the session, sir. Time up.
okay sir. So okay children, the physical properties have started today, and tomorrow we will continue the physical properties, and we will enter tomorrow itself physical property. If physical and chemical properties of the aldehydes and ketones are completed, once we will complete the carbonic acids, so try to practice the named reactions, especially what we have discussed today. Those are very important, either Stephens and Rosenmann's Itard reactions. Okay, these named reactions are very very important. Try to practice those reactions, sir. Thank you, sir. Thank you children.